This lesson is going to examine inequalities and the place where we need to reverse the sign in an inequality, which I'll get to after the introduction. So sometimes, or a lot of times in math, we have the equal sign, right? 7 equals 7, or we want to solve an equation where we have x minus 3 equals 8. And then how would we solve that? By adding 3 to both sides, and we would get x equals 11. So we encounter equals a lot in mathematics. But sometimes we don't necessarily want to examine things being equal, but things being larger or smaller than another number. For instance, if you run a business, you don't want the money you make to equal the money you spend, because then you'd have no profit left over. So, in a business, you want the money made to be greater than the money you spend. Right? So, money made versus money spent. And so the way we show whether things are greater or less than is we use these inequality symbols. So here, what we want in a business is money made to be greater than money spent. And the way I remember the signs, and other people have their own methods, but I kind of picture if you picture a person at the top of the sign, you want to slide down to the smaller number. So the smaller number comes right after the point, or the smaller quantity, and the bigger number is over here. Okay, so you slide down to the smaller number. So, for instance, let's look at some numbers now. If we compare 8 and 7, we want the point to be towards the 7 since the 7 is smaller than the 8. You slide down to the smaller number. Okay. Or again, you could look at it like this. You're still sliding down to the 7. Right? So you can think of it two ways. 8 is greater than 7, or 7 is less than 8. Both are two different ways of saying the same thing. Okay, and now let's look at when we might need to reverse the sign. Okay? So let me give you two examples of numbers. Is 20 greater than 10? Yes. So we have a true statement on the board right now. And as we were working earlier with our algebraic equations, if I multiply 20 by 2, I would need to do the same thing on the other side in our equations to keep it consistent. Okay? Just like if you subtract 3 from one side, you got to subtract 3 from another. If you add 8, you got to add 8 to the other side. So what happens if I multiply both sides by 2? Do I still get a true statement? Is that still true? Yes. What happens if I multiply by 5? 20 times 5 is 100. 10 times 5 is 50. Is that still true? Yeah. The inequality, the symbol still stays the same direction. What happens if I divide by 2? Well, 20 divided by 2 is 10. 10 divided by 2 is 5. Do I still get a true statement if I keep the symbol the same? Yeah, 10 is still greater than 5. Right, so what you're seeing is if I multiply and divide by a positive number, the sign is staying in the same direction. But what happens now if I multiply or divide by a negative number? Well, let's say I multiply 20 by negative 2 and I multiply 10 by negative 2. 20 times negative 2 is negative 40, because a positive times a negative is a negative, and 20 times 2 is 40. And 10 times negative 2 is negative 20. Now the tricky part here is negative 40 larger than negative 20? No, actually. It's worse to be $40 in debt than it is $20 in debt. In other words, if you owe $40, you're further in debt than you are if you only owe $20. Or same thing with sea level. If you're 40 feet below sea level, then you're farther down than you would be if you were 20 feet below sea level. So to maintain this, what we actually have to do now is flip the sign in the other direction, because now, oops, sorry, excuse me. Pardon me. Now, negative 40 is less than negative 20. So we had to switch the sign, right, when we multiplied by a negative number on both sides. What happens if we divide by a negative number? Well, instead of multiplying by negative 2, we'll divide by negative 2. A negative, or a positive divided by a negative is a negative, and 20 divided by 2 is 10. 10 divided by negative 2 is negative 5. And so again, you have to ask yourself, negative 10 versus negative 5, which one is bigger? Well, the negative 5 is actually bigger, even though when you're looking in a positive comparison, 5 is less than 10, but when you're looking at negative numbers, negative 5 then becomes bigger than negative 10, because negative 10 is further in debt. So instead of the sign facing this way, we have to reverse it and move it the other way. So the end result, or to sum up, when you multiply or divide by a negative number, you must switch the inequality symbol. Okay, and so this now concludes this lesson.